In this video, we're going to work on every different kind of percent word problem you're likely to see in a standardized test or typical algebra class. Now, the first thing we have to understand is what a percent is. When I write 80%, what we have to understand is what percent means. What percent means is per 100. There are 100 years in a century, and there are 100 cents in a dollar. So when we say 80%, right, think of it as two words. You can think of this as 80 per 100, and we could also write this as a fraction. 80 over 100. So if 80 is 100% of something, then 50% would be 40, 25% would be 20, and 10% of 80 would be 8. So we can see that each one of these are equivalent fractions. So if I wanted to know, let's say, what 15% was, well, I can find 5% over here just by simplifying this. And to find 15% of 80, I could just add 10% plus 15% would give me, 10% plus 5% would give me 15%, and 8 plus 4 would give me 12. So we can already see all the percentages fairly clearly that relate to $80. So if a dress was 25% off, you would save $20. If tax was 10%, then you would pay an extra $8. Then at the register, you would pay 110%. 100% for your dress plus 10% tax, and that would be 100% plus 10% would be 80 plus 8 is $88. So this is the easiest way to sort of look at percents. Now let's look at the word problems to see how they relate here. Now notice that each one of these fractions are equivalent. This is just a simplified version of that, and so on down the line. A dress costs $80. If tax is 5%, how much total did Mary pay at the register? So if we look at the dress, if we pay full price for the dress, which is 100%, we can see that relationship here. The dress costs $80. And then over here, we either look for what is the tax amount or the tax rate. Anytime they say rate, it's the percent. So over here, they give us a tax rate, which is 5%. So we're matching percents with percents and dollars with dollars. What we don't know is the dollar amount of the tax. So what I'm trying to do is I'm trying to find the fraction where the denominator is 5 that is equal to this ratio. Now, an easy way to attack this problem is to first change all our percents into decimals. So we get 80 over 1.00. Now, the way I change this to a decimal is I move where the decimal would have been. Since that's a whole number, it would be over here, and I would bring it to right there. You always move it 2 places. Again, over here, your decimal would be here, and then we move it 2 places. Since there's nothing there, we have to add another 0. And then I want to do cross multiplication. I want to say this times this is equal to this times that. You can do cross multiplication whenever you have a fraction equal to a fraction. So 1 times x is x, and this is going to be 80 times 0.05. And now when I do this multiplication, I get 400, and then I'm going to move my decimal 2 places, so now I get $4. So this is the amount of tax. So when Mary went to the register, she paid $80 for the dress, and then she paid another $4 in taxes, and what she paid total at the register was $84. A dress costs $80. If Mary pays $86 at the register, what was the tax rate? So previously, they gave us the tax rate and the cost of the dress, and we had to figure out what was paid at the register. In this question, it's a little bit different. They're telling us what's paid at the register, and we have to figure out what the tax rate. So if the dress costs $80 and they paid $86 at the register, we know that the tax, the dollar amount of the tax is $86 minus 80, which is $6. So we know that Mary paid $6 in taxes. Now, the full cost of the dress is 100%, and she paid $6, and we want to know what the tax rate is. That's why it's down here. The tax rate means what percent did she pay in tax. So now, again, we're using equivalent fractions. Now, let's convert this percent into a decimal. So we're going to move the decimal 2 places, and we're going to get 80 over 1.00 is equal to 6 over x. And now we're going to do cross multiplication. This times this is equal to this times that. And I get 80x is equal to 1 times 6, which is 6. And x is equal to 6 divided by 80. And then if we do the long division, 80 doesn't go into 60, but it does go into 600. And then we'll put in another 5. So this is equal to 0.075 decimal, but it's asking for the tax rate, which means that we have to give the answer as a percent. So what we have to do then to convert a decimal into a percent is move the decimal 2 places to the right, and we get 7.5%. And that's how much she paid in taxes. Mary paid $88 for a dress at the register. If the tax rate is 10%, how much did the dress originally cost? Now, $88 represents what the dress costs plus tax. So if we think about it, $88 is 100% of the cost of the dress plus whatever the tax rate was, 10%. So $88 is 110%. It's more than the cost of the actual dress because it contains the tax. Now, what we want to know is how much did the dress originally cost? All right, the original cost of the dress is 100%. And we don't know the value of that dress. So let's convert the percents to decimal. Now over here, we can do cross multiplication, but we don't have to because x divided by 1 is x. So all we're trying to do is figure out what 88 is divided by 1.1. So we get 1.1 goes into 88. Now, in order to do this division, we need to move this decimal out. So we're going to move the decimal 1 place. So really what we're doing is we're dividing 11 into 880. So 11 goes into 88 8 times. And then 11 goes into 0 times. So we get x is equal to $80, which is the original cost of the dress. And we could see that 10% of $80 is $8, which is why they paid $88 at the register. A dress on sale cost $70 after being marked 20% off. What was the original price of the dress? Okay, so this is a little bit different from the previous question where the dollar amount represented the dress plus tax. Now in this one, the $70 is the sale price of the dress. So it's 100% of the dress minus the 20% that it's on sale. So the $70 represents 80% of what the original dress cost. So we get $70 over 80% is equal to Now, the original price of the dress is 100%. And we don't know what it is, so it's X. Now, again, let's convert these percents into decimals. So we get 70 over 0.80 is equal to X over 1.00. Now, we can cross multiply, but we don't have to because X divided by 1 is equal to 1. And then if we do this division, we'll get $87.50. That's a 7 right there. In these next two problems, both of these problems ask the same question, but in different ways. And I want to line them up so we understand the different ways they can ask the same problem. A dress normally costs $80. If the dress is on sale $6, what percent is the sales rate? Now, so let's understand what's going on here. I have an $80 dress, and it's on sale for $6 less, so I'm going to spend $74 on it. Okay, now just keep that in the back of your mind. So we're going to answer this question the way we have been, where we say the dress normally costs $80. So if you're paying full price for that dress, you're paying $80. Full price is 100% of the cost of the dress. Now, it's on sale for $6, and I want to know what the sales rate or the sales percent is. So $6, and here's my percent. Now let's do what we've been doing. Let's convert this to a decimal. And then this is equal to 6 divided by X. And then let's do cross multiplication. This times this times that. And now we get 80x is equal to 1 times 6 is just 6. So x is equal to 6 divided by 80. So now we get x is equal to 6 divided by 80 will be 0.075. And if we convert this to a percent by moving the decimal 2 places, we get 7.5%. Okay, now this question will ask the same question, so let's read it. A dress normally costs $80, is on sale for $74. What is the percent decrease? Now, over here, all the previous problems say, what is the sales rate or what is the percent? None of them said percent increase, percent decrease, or percent change, right? None of them use this word right here. They just said percent or they just said rate. So whenever they say percent or rate, we use this fraction is equal to the fraction technique. Now, anytime they say percent decrease, percent increase, or percent change, we use this new formula. The bigger value minus the smaller value divided by the original value. So when we look at our dress, right, we went from $80 to $74, just like we did over here. So we do the bigger value, which is 80, minus the smaller value, which is 74, divided by the original cost of the dress. So this dress originally cost $80. And then that gives me 6 over 80. Now notice that this right here is exactly the same as this right there. They're the same thing. So in this technique over here, in this question, they're telling us the difference between the two dresses. They're not telling us the original cost of the dress and the final cost. They're giving us the difference. Over here, they're giving us the original cost, and then they're giving us the new cost. So you can attack this 2 different ways. You can use this formula, or you can say the difference between $80 and $74 is $6, and then use this technique. Now, as we see over here, 6 divided by 80 is going to be equal to 7.5%. So you only use this formula when you see the word percent increase, percent decrease, or percent change. So let's do a few more problems like this. Mary received a 15% pay increase in pay. If her original pay is $20 per hour, what is her new salary? Now, in the previous percent increase, percent decrease, percent change problems, they gave us $2 amounts. They would say she was originally making $20 and now she's making $25. That's why we would focus mostly on this side. Now, over here, they told us what the percent increase is. So if we look at this formula, the percent increase goes on the left side. Now, if her original value, if her original pay is $20 per hour, what's her new salary? Now, we know that she was given a raise, so her new value is going to be bigger than her previous value. That's why we're going to go x minus 20. And then we're going to divide that by how much she got paid originally, which is $20. Now we're going to convert this into a decimal. And then we'll put a 1 underneath here, and then we'll do cross multiplication again. We'll go this times this is equal to this times that. So we have 20 times 0.15 is equal to 1 times x minus 20, which is x minus 20. Now, when we do this multiplication, we'll get 3. And then we're going to add 20 to both sides. So her new salary is $23. Now, if you found this video helpful, please like and subscribe so other people can find it. Thank you.